Today we're going to be going over how to calculate molarity given some information about a reaction. So the reaction that we have chosen today is this one. Silver nitrate plus sodium chloride goes to silver chloride and sodium nitrate. This is a useful equation because it's what we use to remove salt from a solution to try to check how much salt was in it. All right, so for those of you who are unaware, AQ means aqueous, and that just means dissolved in something. 99% of the time, it's implied that we are dissolved in water, and I would assume that you're dissolved in water unless the problem tells you specifically that you're dissolved in something else. So the problem says we're going to solve for the molarity of the NaCl solution. So we ultimately want to solve for the molarity of this if 1.5 moles of AgNO3 added to 600 milliliters of the NaCl solution produces 5.6 grams of AgCl. Well, the first thing we have to do, and this is kind of a step zero, you might even take it for granted, but it is important, we can only calculate molarity of anything if we know exactly how much we're dealing with. So we need to make sure that AgNO3 is not the limiting reactant. Because if AgNO3 was the limiting reactant, then we don't actually know how much salt there is because we haven't removed all of it. But if AgNO3 is excess, if we can be sure that we have removed all of the salt, then we can calculate its molarity. So let's confirm this. And how we do it is to check how much AgCl3 could we theoretically create. So let's start with 0.15 moles of AgNO3, and we want to solve for grams of AgCl. So to set up my conversion, once I have moles of one substance and I'm trying to get to some type of information about a separate substance, I'm going to use the mole ratio. Here, it's all ones across the board. So 1 mole AgNO3 for every 1 mole AgCl. Now we need to cancel moles of AgCl and introduce grams of AgCl, and we're going to do that with the molar mass. The molar mass of of silver chloride is roughly 143.3. So in your calculator, you're going to do 0.15 times 143.3. When you do that, you're going to get 21.5 grams, which means if I had 0.15 moles of AgNO3 and infinite NaCl, I could produce this much AgCl. But we know that we actually produced much less than that. We produced only 5.6. So this is proof that NaCl is limiting. We could have made more silver chloride with the amount that we had, but we didn't make more because we ran out of sodium chloride. You can pause your video now to try to figure out why that is true if you don't understand. Once you do accept that NaCl is limiting, then we can use what we know about what we produced to go back and find out how many moles of sodium chloride there must have been. This is going to be our true step one. We have 5.6 grams of AgCl, and we want to know the moles of NaCl. So we're going to do that in a very similar way to what we just did. We're going to use the ratio, we're going to use the molar mass. Molar mass of aluminum chloride is 143. And the ratio of everything up here is 1 to 1. When we go do this math, we do 5.6 divided by 143.3, and you're going to get 0.039. This is really going to help us start to solve this problem, because now we just need to plug in. I have 0.039 moles. And that 0.039 moles was how much sodium chloride was in my 600 milliliter sample. When we're plugging this in to solve for M, molarity, we can't plug in milliliters, we have to use liters. To convert from milliliters to liters, you're going to divide by 1,000, and we're going to plug in 0.6 liters. Now, when you solve this, we're going to find out that the concentration of this salt solution was 0.065 molar. 0.065 molar. Now, as a bonus, let's try to figure out how much AgNO3 is left over. To do that, we're going to have to remember back to step 0, right? That step to make sure that NaCl was limiting, and remember that we said we could have produced 21.5 grams of AgCl. Could have done that. In reality, though, we only made 5.6. So we need to figure out what the difference is. To do that, we're going to just do some simple subtraction here, which is probably going to take me longer than it should. The difference, 15.9 grams of AgCl. Now, we need to figure out how many moles is 15.9 grams of AgCl. We're going to be using our molar mass. You're going to solve for moles of AgCl, and that moles is going to be the same as the moles of AgNO3 that are left over. And the reason why is because the ratio is 1 to 1. Hopefully that helps. For calculating molarity, this is a very specific example, but it's a good one, and its setup can be applied to many different problems.